Okay, in this video I'll go through something called logarithmic differentiation. Let's take the example. Let's say we have a function y equals 2 to the power x. Now how do I find dy over dx for this function? Now one thing that might pop into your mind is that we've seen already that if you have a function x to the power n, then the derivative is equal to n times x to the power n minus 1. But remember, this rule is only valid if the power is a constant. Here n is a constant, but in this case my power is not a constant, my power is x, and that's a variable. So in this case you cannot use this rule, and sometimes you might mistakenly write this as x times 2 to the power x minus 1, but that would be wrong because this only works if the power is a constant. So in this case what we do is first take logarithms on both sides. So I have ln of y is equal to ln of 2 to the power x. Now the right hand side can be written as x times ln of 2. And if you remember rules of logarithms, this is called the power rule. It says if I have ln a to the power b, then I can take the b to the front, and this can be written as b times ln of a. So similarly here x is my power, I can take the x to the front. Now ln2 is just a number. ln2, I think that's approximately equal to, it's approximately equal to 0.69. And now we can differentiate both sides with respect to x. I want to find dy over dx. Now differentiating the left hand side with respect to x. Now differentiating ln y, I would get 1 over y, but since I'm differentiating with respect to x, I have to add on a dy over dx. And we've seen this when we did implicit differentiation, and I am doing implicit differentiation here. Now the right hand side is in terms of x. ln2 is a constant, so I have ln2 times the derivative of x. The derivative of x with respect to x is equal to 1, and then I have dy over dx is equal to, multiply both sides by y to give y times ln of 2. And then I can write my right hand side in terms of x, because y here is equal to 2 to the power x. So I can rewrite y as 2 to the power x times ln of 2. And that would give dy over dx for 2 to the power x. And you would want to use this logarithmic differentiation where you take logarithms on both sides and do implicit differentiation if your power is a variable. So let's take another example. Let's say we have y equals 2 to the power x plus 5. Once again, my power is a variable, so I'll take logarithms on both sides. And you can take logarithms to any base, but it's easy if you take ln y because it's just easier to differentiate the natural logarithm. So ln y is equal to ln 2 to the power x plus 5. Then rewrite the right hand side as using the power rule, bring the power to the front. So that's x plus 5 times ln of 2. That's equal to ln y. Then differentiating both sides with respect to x, I get 1 over y times dy over dx is equal to, ln2 is a constant, so I get ln2 times the derivative of x plus 5 is just 1. So I get dy over dx would be equal to y times ln of 2, and I know that y is equal to 2 to the power x plus 5, so this gives 2 to the power x plus 5 times ln2. Okay, let's take one more example, a slightly harder one, which involves the product rule as well. What if we have y equals x to the power x? Once again, my power is a variable, so let's take the natural log on both sides. So I have ln of y is equal to ln of x to the power x, and I can rewrite the right hand side as x ln of x. So that's equal to ln y. Now if I differentiate this with respect to x, once again I get 1 over y times dy over dx is equal to, now ln x is no longer a constant, it's not just one number. I'm going to have ln x is also a function of x. So here I have a product. So I'm going to use the product rule on u and v. So if I use the product rule, I get x times the derivative of ln x, that's 1 over x. Then I got plus the second function, which is ln x, times the derivative of the first, so the derivative of x is just 1. So I have 1 over y dy over dx is equal to, I can cancel off this x and x, so this just gives 1 plus ln of x, and then cross multiply by y to give dy over dx. So dy over dx is equal to y times 1 plus ln x, but I can rewrite y as, I have y equals x to the power x, so I can rewrite this as x to the power x times 1 plus ln of x, and that gives dy over dx.